Okay, so today we're going to talk about, or at least this video, we're going to talk about translations of trigonometric functions. And first, you just flat out need to know this general equation for a trigonometric function. And when I say general, all of these are constants, a, b, c, and d. And where it says sine right here, that could be cosine, cosecant, secant, tangent, or cotangent. Any of the 6 trig functions. And if you hopefully reviewed the other videos that are show how those parent functions are graphed. And so let's talk about, today we're only going to talk about the following 2 things. We're going to talk about this value c and this value d. D is the easiest of them all and the easiest between these 2 translations. And I'm going to refer back to something you should already be familiar with so we can build from there. So let's just go back to that reference. We're going to slide over this way and we're going to talk about the function y equals x squared, which of course hopefully you recall is a parabola. And it would look something like this. And it's a little crooked, but that's, I think, going to be good enough. So y equals x squared may look something like this. Disregard the grid. This is not to scale by any means. And then I'm going to write another function here, y equals x squared plus, let's say, 3. Y equals x squared plus 3 is exactly this parabola, the purple one, except it's shifted up 3 units, right? So shifted up 3 units in the positive y direction. And so we get that, or something like that. So it's the exact same parabola, no changes. It's the same size, everything. It's congruent, except it's shifted up 3 units. And if, of course, I had y equals x squared minus 2, this would be exactly the same parabola again, except it would be shifted down 2 units. These 2 units here, so we got to negative 2. This one was up at 3, and this one was had its vertex at 0, 0. So that's what we're talking about with the d value. This works the exact same way. If we go back to here, this whole thing generates whatever's going to happen to the function. And then if I compare this to this and say that all of this is the same as what's here, then all that this d does, whether it's positive or negative, is shift our function up or down in the amount of d. So as an example, we get y equals sine x, which is the parent function of sine, and that looks again like this, or something like that, right? Where this is at the origin, this peak is at pi over 2, this crossing again is at pi, this trough or bottom is at 3 pi over 2, and of course the period is 2 pi. If I had the function, we'll change colors, y equals sine x minus 2, and this is at 1 and this is at negative 1, I would have the exact same function except it's shifted down 2 units. So this would, instead of being at 0 here, it's now at negative 2. And so I can draw a new midline and basically draw, let's see if I can match this up fairly well, and draw a new function that horizontally nothing's changed. This is at 2 pi, this is at 3 pi over 2, this is at pi, and my drawing's not really very nicely done to scale, and this is at pi over 2. Everything's exactly the same except we've shifted down 2 units. Every single point is shifted down 2 units. Because we had this minus 2 tacked on the end. So that's a vertical shift. If it was plus 7, we would go up 7 units from the original parent function. So let's go back and look at this again. We had this written down, y equals a sine of b parentheses x minus c plus d. And so we've talked about that. Let's now just examine the following. Sine of x minus c. This minus c works very much, in fact, just the c, the minus sign is part of the function. It's part of the function. So this c works exactly like a parabola, and we'll go for here to the right and look at that again. So if I have a parabola y equals x squared, that again looks like this. Oops. That again looks like this, or something like that, right? And then if I have another function, y equals x minus 3 squared, I'm hoping you recall that this 3 is a shift to the right, because this part right here, which in vertex form of the parabola, x minus h squared plus k, the h value is 3. So that's a shift to the right of 3 units. So the parabola would be exactly the same, except it's over here 3 units to the right. If, in contrast, I had y equals x plus 2 squared, that would be like writing y equals x minus negative 2 squared. I would take the parabola and shift it to the left 2 units, so its vertex was at negative 2. Okay? So in the same way, the trig function works the exact same way. So let's look at an example. Y equals cosine x. Let's look at the parent function. And so we're going to look at the parent function. Let's see if I can draw this a little better. Okay, the parent function of cosine, this is at 2 pi, this is at 3 pi over 2, this is at pi, this is at pi over 2, and this is at 0. Has a height of 1 to negative, and a negative height of negative 1, or what do you want to call it. It goes from negative 1 to 1, the domain. And if I compare that to the function y equals cosine of x minus pi over, I guess, pi over 3. Let's say pi over 3. So it's kind of weird. So pi over 2, pi over 3 is approximately here. So instead of this point being there, I'm going to shift it over a distance of pi over 3 to the right, again, because this minus sign is part of this minus sign right here is part of the function, right? So we're going to take this and we're going to do the following. And this shifted over to the right pi over 3. This shifted pi over 3. This shifted pi over 3. These values shifted over pi over 3. This shifted over pi over 3. And again, my scale is not perfect, but I shifted to the right pi over 3. If I draw a third function in here, again, we'll change a color to, I don't know, blue. Y equals cosine x plus, and let's actually just do this just like we should, minus negative, I don't know, pi. Then that means that this point's going to shift to the right a total distance of pi, which means we kind of got to go way over here. And I'm not crossing over the right values, but this would, actually it's not too bad. This would be at pi, this would be, really it should be over here at the 0. But it's gonna, everything's going to be to the left pi, a distance of pi. Okay? So that's how horizontal and vertical translations work with the trig functions. They work exactly the same way as any of the polynomial functions like the parabola. All right? So that's what we got.